Hi everyone, and welcome to this tutorial guide for Oxygen Not Included, which is all about rocketry in the Spaced Out DLC. This guide is a comprehensive look at all aspects of rocketry, including all of the mechanics and how and why to set up space missions. Rocketry for the base game is quite different and will be covered in a separate tutorial bite. So jumping right in, before you can go to space, you need to find where to go. The star map is available in the top right or on the Z hotkey. It is arranged in hexagons or hexes, with the starting planetoid at or near the centre. From the start, only this can be seen, and to find more needs telescopes. There are two types of telescope, open and closed. The closed requires power and oxygen and can reveal 4 hexes away. The open telescope is simpler to use, only requiring power, and can reveal 3 hexes away, as well as being usable inside rockets. Start by exploring around the home planetoid, then use rockets to explore further, which I will explain later. The full star map looks like this, and is different for each map seed. Rockets move from hex to hex, using 1 unit of range for every hex. There are 3 types of non-empty hex, these being planetoids, their orbits, and points of interest. Planetoids can be landed on, and their orbits are the purple rings. Rockets will not move around the orbits by themselves, and moving around these, or up and down from a planetoid, all require 1 unit of range. The points of interest can be visited, and will return either artifacts or useful resources depending on the type. There are infinite sources of many materials in the late game, and I will explain how to do this later. So having looked at where to go, I'm now going to cover the mechanics for building rockets. This is all done through the rocket platform building, which requires 800 kilograms of refined metal. It does not need to be placed on a floor, and makes its own walkable floor along its top for dupe access. From here, new rockets can be built and existing rockets can be modified. Adding modules is done with the plus button. Modules can quickly be swapped up and down using the arrows and can be done even once built. And they can be swapped with the cog button. You can also have dupes deconstruct modules with the deconstruct icon, but this can be done automatically by changing the module, then cancelling the design. Ladders are the simplest way to access the building and loading of rockets, and typically run up the side of the platform as shown. As dupes can reach 2 across, this is close enough for building the modules, but for loading tasks, such as Oxidizer, you'll need to put a ladder segment closer. Gantries can be used, but I see these as a relic from the base game since they are unnecessary and require significant amounts of power and steel. Every rocket has the same key elements, and every module can be categorized into one of 5 types. These are engines, which must be at the bottom, fuel and oxidizer tanks required for certain engines, crew modules, nose cones, and utility modules. All rockets must have at least an engine, crew module and nose cone, and note that the Solo Spacefarer module is both a crew module and a nose cone. Rockets are limited in height by the engine choice, with late game engines allowing bigger rockets. Utility modules include storage for gases, liquids and solids, and these are loaded through the port loaders. These attach to platforms and can be joined to each other and will connect to all other joined platforms. Connect the desired inputs to the loaders and enable the filter on the storage module to fill. Unloading uses the unloader buildings in a similar way. These cargo modules cannot store extra fuel or oxidizer to be used in flight, but could be transferred once landed. Materials stored in the modules can be used in the rocket interiors using fittings. The Solo Spacefarer and Spacefarer modules are the 2 types of crewed module, and have interiors that can be highly customized. A really useful tip here is to counterintuitively place the Spacefarer module as low as possible, to minimize piping and laddering required. Clicking on the module and then View Interior will show the inside. This starts with only the rocket control station and can be freely built in, allowing for many designs. Note that this station can itself be deconstructed and relocated for complete flexibility. These modules have direct gas and liquid input and output lines to move materials inside for the crew. In order to keep dupes alive, oxygen and food are a minimum, and toilets and beds are obviously good inclusions. Food is the easier topic, and the best foods to use are those that spoil slowly or not at all. The starting nutrient bars, as well as the starting plant, Either muckroot, excellent fruit, or swamp chard heart all do not spoil. The only non-spoiling food that can be made is berry sludge, produced in a microbe musher with bristleberry and sleet wheat grain. Earlier on, pickled meal is a great choice as it has a long base spoil time of 16 cycles, and this can be extended in a powered fridge. Oxygen is more interesting, and there are many solutions that can be used. The first is actually to not supply any at all, and this can be done using a strange behaviour with atmosuits. This happens when dupes run out of oxygen reserves in a suit. They will keep recovering breath, but when doing so consume no oxygen. This means they no longer require any oxygen supply, which makes this very useful inside rockets. It's unclear if this is intended or a bug. But to actually provide oxygen, a simple way is to generate oxygen inside the rocket, for example with an oxygen diffuser. However, the carbon dioxide must also be dealt with, and a mini gas pump can be used. The next way is perhaps the most obvious, and this is supplying it from a gas cargo module. Either a small or large module can be used, but the disadvantage of this method is the valuable height used in the rocket. Oxygen is then piped into the external module through the gas loader, then accessed in the interior from a gas output fitting. There is another little trick here in using a gas vent at floor level, as this has the additional advantage of deleting small carbon dioxide packets. The pipes can also directly feed suit docks. To avoid using rocket height, there are two further methods, and the first is storing oxalite in a storage bin. This will off-gas over time, supplying oxygen, and is a neat and simple solution assuming you can make it. Placing this at floor level will also delete the carbon dioxide. And finally, the last method to mention is infinite storage. The way to do this is by using a small tile of liquid to prevent the gas vent from overpressuring. A gas pump is then used to supply the interior vent and suit docks. I prefer this method as it has both the advantages of a piped output and saves rocket height, but it's up to you if you want to use this. In addition to food and oxygen, morale is useful to think about, and room bonuses can be made inside, with 3 that are typically used. The Great Hall is easily made and gives a large +6 bonus, so should be prioritised. After that, make a bedroom or bathroom or both if possible. For a final tip, the rocket control station has a grounded setting which prevents dupes from using the building's inside when landed. This is helpful to prevent dupes from sleeping, eating, or using the toilet here instead of in the base. It can be disabled in chosen buildings to allow loading. I'm now going to quickly touch on controlling rockets, and this can be done from the exterior on the crew module or from the rocket control station on the interior. From here, the destination can be selected and the required and maximum ranges are shown. Crew is also selected from here on the Change Crew button and must include a pilot to take off. The settings here allow either all dupes to access the module or only the crew. If crew is selected, then the crew will be summoned and all other dupes will be not allowed in and forced to leave. Hitting Begin Launch Sequence obviously prepares the rocket to go and also summons the crew, so you don't need to do this beforehand. Beware that when rockets launch, they will leave a hot exhaust behind which can injure dupes. Moving rockets in space is similarly done by clicking on them. Be careful not to strand rockets in space, as if they run out of fuel, the only way to recover dupes and materials is to abort, which will send them to the nearest planetoid. Trailblazer, rover and orbital cargo modules can be deployed from here too when in orbit. The key choice when building rockets is the engine, as it has important stats. The two most important of these are the range and maximum height. Range is limited by the amount of fuel stored, and for many engines this is fixed, as the engine directly stores the fuel. Only petroleum and hydrogen engines use fuel tanks, meaning their range can be increased at the cost of rocket height. Height is simply the maximum allowable tiles of all the rocket modules, including the engine. As each module obviously has height, this limits how many modules can be used. Touching quickly here on oxidizer, this is needed for sugar, petroleum and hydrogen engines to burn with the fuel. How much is required depends on the type used, and for fertilizer it must match the fuel amount, so one large oxidizer tank per fuel tank. Oxalite is twice as powerful, so one large oxidizer tank can match 2 fuel tanks. Liquid oxygen is the best and is 4 times as powerful, and again one liquid oxidizer tank matches 2 fuel tanks. But the advantage is the module height of 2 compared to 5 for the solid tank. I will have a dedicated tutorial bite for making liquid oxygen and hydrogen. But what this means is that liquid oxygen is never required in the Spaced Out DLC, unlike the base game, but instead gives the useful height benefit. Moving on, I'm showing here a summary of all the engines and their key stats. The early game engines have low range and height, which are improved with later engines. These later game engines require more research, but are required to really explore space. Note that the small petroleum engine can be run either with or without fuel tanks, and the large petroleum and hydrogen engines require fuel tanks. The more fuel and oxidizer tanks that are added, the further the range but at the cost of less usable height. I've also given here the usable height left, which is the height remaining after accounting for the engine itself and fuel and oxidizer tanks. Most engines also generate power when in flight, which is useful in the rocket interiors. The final difference is speed, and the engine power is given here. A rocket's speed is given by its total burden, which is like a module weight, divided by the engine power. From a practical perspective, the late game rockets are quicker, and beyond that, I don't consider this to be particularly critical. So having covered how to build rockets, the most important question to ask is why, and this must be kept in mind when designing rockets. Always design a rocket for a specific purpose. From my experience, there are 4 main purposes, and therefore types of rocket that need to be built, and I'll now go through each one. The first is a research rocket, and this is needed to make data banks used in data analysis research. I explained this in the tutorial bite for research, so we'll only briefly show an example here. The carbon dioxide engine or sugar engine are good choices, and help unlock the other engine types. Inside, very little is needed beside the orbital data collection lab, with plastic, as this rocket only needs to go to orbit and back. Using the suit trick is ideal, and if not, then oxygen can be stored in pipes to keep the rocket supplied for short trips. Secondly, the next type of rocket is for telescoping, which will unlock access to the whole star map. There are 2 ways to do this, but both involve sending out a rocket towards the undiscovered space. Firstly, the open telescope can be used inside a Spacefarer module, and the rest of the interior simply supports the dupe. To use the telescope, the dupe must have the astronomy skill. The suit oxygen trick also works here, as dupes do not need to leave the rocket. Alternative to the telescope, the cartographic module can be used, and this discovers visited hexes and nearby points of interest. Range is an important point here, and the later game engines will be needed to discover the edges of the star map. Remember to factor in fuel for the return trip. The next type I'm going to cover is usually the last type to be built, and is a mining rocket. This has a drill cone that takes 1 ton of diamond and recovers 20 tons of material from space points of interest. Make sure to include material cargo bays to capture the resources you want, and be aware that the small cargo bay can run out of space before all the diamond is consumed. For the interior, the dupe simply needs to be kept alive, and the suit oxygen trick can be used. These rockets are then sent out to the points of interest, and mining will begin. The resources will be distributed according to the percentages, regardless of the material bays used, and any other materials will simply disappear. Over time, the resources will recover, making this a sustainable method of collecting them. Just be sure to visit enough locations with coal or refined carbon to make more diamond from in the diamond press. This also requires large amounts of rad bolts, as I covered in its own tutorial bite. The other points of interest simply give artifacts that are collected with the artifact module. These only give a decor bonus, so are nowhere near as useful. And the final type to cover is the most versatile, and this is for long-term living. This type of rocket is ideal for colonising new planetoids, or simply moving dupes about. The exterior can vary depending on the needs, but solar panels and a battery are useful, and Trailblazer modules are used to land on new planetoids. I will explain how to land and colonise new planetoids in its own video. The interior is the most important part of this rocket, and here is where you can be creative. Atmo suits are extremely useful and need an oxygen supply. Besides that, the goal is simple, and having a livable area makes missions much easier. This design combines the oxygen and food storage, along with the Great Hall room bonus as I described earlier. With the ability to support dupes for long periods, this gives dupes flexibility to dig and build on other planetoids. And that's all for this comprehensive look at rocketry in the Spaced Out DLC in Oxygen Not Included. I hope this helps you conquer space, and thanks for watching.